lot, seriously, there's a lot to this. The reason why I want you to see it is kind of twofold, multifaceted. One, actually it's threefold. If you ever dabble in the old biochemistry realm, which means take human anatomy and physiology, a huge proportion of physiology, not the anatomy side of things, is truly biochemistry, except it doesn't get talked about, which is perfectly fine. There's no rebuke there at all. But it typically in a high school setting gets more of the approach from a biological standpoint than it is the biochemical standpoint of tracing carbons, moving things through organs, what is the actual chemical reaction, etc. So if you ever dabble in that, human anatomy or biochemistry, then this certainly would be very, very helpful for those things. In addition to that, we've already argued maybe food labels, t-shirt stuff, checking out a mommy blogger website and being like, hey, that doesn't quite line up with the scientific research says. Being able to Google the scientific name, not that you couldn't do that anyways, but it's definitely different than the mommy blogger who potentially says a whole bunch of stuff about a whole bunch of things and really has no peer-reviewed literature to support what she's saying, right? Or mommy blog or daddy blogger. I didn't mean to just say mommy, but anybody who's blogging in there whatsoever. I typically just don't say daddy to blogger.
Is there really a dad blog?
I'm sure there is.
You just say blogger.
Bloggers.
Yeah.
That's bloggers. Kid bloggers. Yeah. Okay. And the third part of that would be arguably like in your medicine cabinets, if you have something of that nature, wherever you keep those medicines, picking it up, you read the label. One, you probably shouldn't just take it if you don't know what it is, but being able to see the scientific name, it could be helpful at some point to be like, oh, this is the same thing as this. Why are they labeled two different ways? This is the generic brand, this is the non-generic brand, this costs a little bit less, this is way more expensive. My doctor gave me this and I can get this at the store. You know, like kind of have that conversation a little bit, because eventually, as you start getting old or having kids or whatever that is, those things would be more realistic situations than just saying, you're going to look at a food label and try to understand the scientific language there. Okay, so there's what we'll do is we'll list out several different parts of the organic nomenclature system, and then I'll tell you how to name everything. So let's just kind of get down the terminology, and then we'll move on with that. All right, suffixes, ein, in, and ein is how you say that. So this is a single through triple bond. And if you look at the front side of that handout I just gave you, it does tell you, in general, the biggest picture concepts to keep track of in terms of the order that things are ultimately going to be named. So doubles or single, double, triple bond, ein, ein. The alkyl groups. So whenever we say methyl, that's different than if we say ethyl, propyl, etc. So this would be in terms of lengths of carbon. So maybe I should say bond type here, if we're just kind of categorizing things. Length of carbon. Okay, so this would be 1, 2, 3. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl. Very similar to what we did yesterday, right? You can see some similarities there. And then if we keep going with the same sort of language of our prefixes, what would come next? Heptyl, so hexyl, pentyl, hexyl, heptyl, octyl, nonol, and decyl. Okay. And again, some of these are going to change in terms of the endings. Like we may not need the YL ever, or we may need the YL. We might not need to put the E at the end, or we may need to. I'll show you how to do all that in a little bit. Okay, so those are the carbon units with the alkyl groups, also known as metric prefixes. Hey, hi. So the monoditrite monoditrite, tetra, penta, hexa, hepta, octanol, and decyl. So we still need those prefixes additionally as well. All right, a few other things. Let's go.
Don't erase it. I'm still writing.
Excuse me, Mr. Morgan.
Yeah.
What does that say about methyl? Like how you?
Alkyl groups.
Alkyl?
Yep.
Okay.
Alkyl groups. Those are going to be our attachments. There. Functional groups. We got a few of those that we'll use. There's lots of different ones, but we're going to just pick and choose the ones that are a little simpler for us to work with. So we have CH3, that's the methyl group. We could pick that up here as well as being one carbon. We have OH, that's the hydroxyl. Also, formally this in general for the rest of the year. Alcohol group, for sure.
Alcohol or
Sorry.
alcohol?
And then in addition to that, iso,
Ignored your question.
no, so alcohol group.
Okay.
Isopropyl. Would be the carbon.
Whoa.
Looks like this.
Just slow down.
Very similar to what it might look like if you're propyl, right? You see 3 carbons over there, but how they're attached is actually going to be important as well. Fluoro, chloro, bromo, etc.
Like, we need to know that, or like?
Yeah, but they're all following a similar pattern. So this would be fluoro, FLUORO, chloro, bromo, and iodo. So a lot going on, but it is systematic and it will come together to be a little more straightforward. Not simple, just straightforward. Okay. All right, let's do,
Can you like comment? Yeah, wait a second.
yeah.
Is there like an ending to the fluoro, or is that it?
These lines in essence mean so there's these hyphens are not actually hyphens. There means there's some other stuff bonding here, but when you see this, you say methyl. Some other stuff bonding over here, you see this, you're going to say hydroxyl. So these are actually, I did flip that around, these are actual groups that are going to be bonding to our complex structure. And then we need one basic idea, saturated versus unsaturated. Think back to biology class. What's the difference between saturated fatty acids and unsaturated fatty acids?
It's a great question.
What type of bond? Right.
Carbon one?
Keep going. Yeah, it is.
Hydrogen?
With all hydrogen? Yeah, carbon with all hydrogen would be saturated. Carbon with double bond nature would be unsaturated compound. So that's bonding twice to carbon when it could be bonding to more hydrogen. So here, in essence, what we're looking for is single bonds, typically associated with hydrogen, carbon-hydrogen bonds. Whereas here, we're looking for double bonds or triple bonds. And then one kind of side point here, whenever you see something that's not in a straight chain, I shouldn't say linear, but I'm going to. Maybe straight chain.
Is that C4?
Where are you at?
What you just wrote?
Cyclo.
Oh.
That's a Y.
Oh.
That wasn't much
Well,
better,
why
was
is
it?
it C capitalized? I was just asking.
Cyclo. Cyclo meaning some sort of cyclical nature to it. Also, carbons binding together in some sort. It doesn't have to be a circle, but it could be a hexagon, a triangle, something like that. Linear straight chain will have the general shape of, in general, moving across the board in one direction. So a little bit of a different idea there. And then big picture concept. This showed up a couple times already as well. We could more easily put something like, let me do a couple examples here. Okay, so something like this, where you go ahead and you saturate that carbon, or every carbon, with hydrogens. Takes a lot of time to write all those hydrogens, right? like good night. We could have made that point so much simpler. So oftentimes it is acceptable to do things like, let me go ahead and do this third one so it looks a little better. Okay. This is called, what is it called? I don't remember what it's called. I call it branch chaining, but I know it's not the actual word. But notice that we have a couple different points of location. Each individual end or two junctions or a junction where two lines meet would be a carbon. So instead of writing it as this, we can just draw this. That gets the general idea across up here. We make the assumption that there's a carbon at every single spot, and every single carbon has the appropriate number of hydrogen bonds still there, unless there's something else present. So in this case, if there was like a fluorine attached here, we could still draw this structure, except we would have to put fluorine here, because everywhere else is assumed to be carbon and hydrogen. Kind of nice. So this one, of course, you could do all hydrogens everywhere else, and then you have this. Again, if you had some sort of fluorine component here, maybe you have to do O and fluorine attached there. So that would be a carbon 1, carbon 2, carbon 3, carbon 4. Okay, kind of makes sense? So it's going to save us a lot of time to do that. Okay, let's do a few examples here. I'll try to keep all this up as we're
Wait, I
doing.
have a question.
Yeah, go for it.
So, once we get to the length of carbon is 5, it starts to go with the pentohexyl, those
Yep.
things. Why are the first 4 weird?
What do you mean? Oh,
Like,
just
why
in
is
terms
it
of naming?
U?
I don't know. I don't know how that originally started. I really don't. I mean, this is like you're saying, based on the general consensus of prefixes, but originally I don't know how those words
Because the
were
only
chosen.
ones I actually understand for why they would change is mono,
Yeah.
di, and tri. But
Yeah,
tetra?
Yeah.
To
don't know how it
U?
originally started. All right.
Huh,
Yeah, you're going back into the history. I don't know the history of that.
interesting.
Okay, let's do a couple examples here. Let's just kind of work in order. Methane, right? We already have that. So this is meth. Notice it's 1 carbon, meth. And then if that carbon is single bonds, which there is only the possibility of single bonds here, then this is methane. So this is a single bond. And this is the length of carbons, so a number of carbons. I'm going to call this the parent chain. So it's the number of carbons on the parent chain, and then because the parent chain can have things branching off of it. Okay. Let's do another one. So let's do ethyl. So ethyl means 2 carbons. So that's ethyl. And then if they're all single bonds between them, or between the carbon, single bond, then it's ethane here. So we get rid of this YO notation, because that's acting as something where it's binding. And now move those 2 together. Ethane. So this is 2 carbons on the parent chain that are all single bonds. Okay. What would ethene look like? And these are all hydrogens. But
There's a double bond.
yeah, double bond. So you could redraw ethane just as, I mean, that's not as official in the scientific community. Be like, oh, a straight line represents ethane. Nah, not usually. Just as fast as that. So double bond carbon. So if you have 2 carbons, it's still F. If they're double bonded between, it's E. And then hydrogens everywhere else, right? What's ethyne?
Just 1 hydrogen bond, right?
Okay, 1 hydrogen bond. So 2 carbon chain with a triple bond, ethyne. And then you do the same thing for propyl all the way through decyl. But let's just pick and choose a little bit here. We don't have to do all of them. All right, what's this? What's that?
Mountain range.
That's true.
Oh, pencil?
Okay, so So 1, 2, 3, 4, 5, that's pent.
How do you show double bonds with your shorthand?
Yep, I can show you that too in a second. And then are these all single bonds between there? Yep.
Yes.
So that's the aim. If we want pentene, we can do this. So still 5 carbons, but there is a double bond.
Is that the only mark you need to show that the whole thing is
Yeah.
double bond?
That's it.
Oh.
Yeah, it's not nice,
That's so nice.
isn't it?
Can
Otherwise,
we do that on our assignments?
yeah, absolutely.
Okay, wait, let me write it down.
I got a C on one.
But now it gets a little more
I did that
complicated.
instead of all the dots.
Alright, because we could do the same thing, but couldn't we put the double bond here? Yeah, and we could put it here, we could put it here. And it's like, how do you denote the difference between this pentene and this pentene? Because chemically, they would react very differently, fair? Yeah, you have to number them. You have to number them. So here's how we number. If you look at the front of that handout I gave you, it's going to give you a bullet point list of a few things to consider. One of the things you consider is when you're numbering, you actually number these as the highest priority items. Okay, so functional groups get the highest priority, and then we want to go for the longest parent chain as well. So this would have been like bullet point number, there it is. Bullet point number 4, 2 or more functional groups, the hierarchy must be established, the highest priority functional group added to the suffix, while the other ones are substituents. This little middle area here is trying to help us understand the hierarchy of these. If I have a hydroxyl attached and I also have a fluoro attached, who has the greater priority based on the hydroxyl? So that's how we would start numbering, is trying to number the lengths of carbon, giving the lowest value possible to here, and then subsequently working our way up through here. All right, look at bullet point number 5. It says, go ahead and number the parent chain in terms of making it the longest, and then include double bonds in there. That'd be number 6.
Going back to the hierarchy?
Yeah.
How do you know which one of those, like which one of the ones on the board fall
Yep.
under which ones here?
These would be halides. So alkalides, not alkalides, halides would be here. So halogens. And then the alcohol, I give you that one. And then you don't have any carboxylic acid, ester, no aldehyde, no ketone, no amine, and no ether. So yeah. And then this is just an alkane. So alkane, alcohol, this is an alkane, and these are halides. So
How do you know that?
halogens have the same language. Alkane means single bonded carbons that are there, and this is the actual notation for an alcohol.
So halogens are the halides?
Halides, yep. Okay, let's do a few here. All right, so we need to number this chain. Don't write this down. Let me write a couple of versions, and then you write the right version. Version 1 could be, this is carbon 1, 2, 3, 4, 5. That's one version. And if we did that, then this name should no longer be pentene. The double bond begins at location 4. So that would be 4-pentene. If we decided instead we wanted the numbering system to be something like this, 1, 2, 3, 4, 5, then the double bond begins at location 1. Which one of those is better?
The first one?
We want the longest chain possible, fine. We have 5 either way. We give the lowest number to the highest priority item, and in this case, the highest priority item is the only item, the double bond, because there's no functional groups hanging off the sides of anything, right? So the numbering system, putting a 1 here, is better than trying to put a 5 there, because we're trying to give the highest priority item the lowest number possible. So this would be 1-pentene. If in the scientific community you saw 1-pentene, a lot of people would just say pentene and not worry about the 1, because that implies that the 1 location, carbon 1, has the double bond. Another additional way that people can do it is to say pent 1-ene, Oh, let me step back. Whenever you have, like if you have two numbers together, you separate them by a comma. Whenever you have a number with letters, A, B, C, D, whatever, you separate them with a hyphen. You can throw in a hyphen with more numbers if you want to. And you can keep going with more letters. So that's the general notation. Numbers need to be separated by commas, and numbers and letters need to be separated by hyphens. And it doesn't matter how many of those you put in there for us.
Hold on, I'm gonna
So this is implied, having the carbon or the double bond at position 1. What does this say? This says I have a 5 carbon chain with a double bond at position 1. That's what that says. This says at position 1, there's a double bond on a 5 carbon chain. Yep. How would we number this one? Would I go 1, 2, 3?
Sure. Yeah.
1, 2, 3, right? And this would be 4, 5. So the double bond begins at position 2. So this is 2 pentene. I can't say pentene, but I could do something like this. So I could say pent 2-ene. So there's a 5 carbon chain that has a double bond at position 2. Fair? So it doesn't matter to me which one of these you use. We'll kind of go back and forth on that.
Are you numbering those correctly? Like, is that actually how you're supposed to number them? Oh, okay, so.
You always go right to left.
No right to left, no left to right.
It depends
It
on.
depends
what
on the
double
lowest
bond
priority
is.
item. So this is giving the 1 to the double bond, this is giving the 2 to the double bond, versus if I started here, 1, 2, 3, 4 would be the double bond. If I started here, 1, 2, 3 would be the double
So you
bond.
want the lowest number.
You want the lowest number possible on the highest priority item. And there's only one priority item here, which is the double bond. We could arguably do something, and we will, but don't do this quite yet. If we throw in another item, and by item I'm using item pretty generically right now, and instead of using the word functional group or suffix or prefix, so just item. Now we have to consider, does this have more priority than the double bond, or does the double bond have more priority than the alcohol? Because that could change how we end up numbering stuff.
The alcohol.
And then if we even have, let's say, like maybe two different items that are similar, that could still change it. And if we even put on maybe different items altogether in general, now that really changes things. So we'll do that. We're building up to that, but we're not there yet. Yeah.
So what if you put the double bond at like where the 5 is? So
Let me read it all. Go ahead. Say it again.
where like the 5 was? Like
So
in-
here?
Yeah,
Yeah.
so, and then, yeah.
Yeah.
So would that start the numbering process on that
1,
side?
2, 3, 4, 5.
But it's always chronological.
What do you mean?
Like it always goes 1, 2, 3, 4,
Yeah.
5. You can't start with 5 or like 3 and count up and then
Right.
back down.
Right.
How would you number it if there was like a hydroxyl
Yep.
attached?
We can. So let's add, let me go back to where we had the double bond. Here. Okay. We can put the hydroxyl wherever, it doesn't matter. Let's keep it simple and then move it around. If I put the hydroxyl here, is that okay for this carbon? Can that carbon still have 1, 2, 3, 4 bonds?
Yes.
Yeah.
Okay, that's fine, no violation there. If we do that, the highest priority item is the functional group. I think that was bullet point number, here it is, bullet point number 1. This is the order that we're gonna write. Stereoisomer means this. You might just say this is stereoisomer. Substituents are gonna be additional things that come from this list that we don't prioritize as the first.
Wait, what was stereo rice?
These are stereoisomers.
Oh, saturated.
These are functional groups, but based on bullet point number, where was it? What did I say earlier? Functional groups and yeah,
Is the
bullet
word
point number 2.
stereoisomer?
How
Bullet
do you
point,
spell that?
bullet point number 1.
Okay, that's what I wrote pencil. That's it.
Oh,
So stereoisomer is referring to cis and trans saturated, or cis and trans, which means saturated versus unsaturated. We're not going to do anything with that. It's just if you come across it. And then these are functional groups, but sometimes these functional groups, if this has the highest priority, then everything else would be named as substituents. So you can consider sometimes functional groups or substituents. the halogens, so these, the halides, are typically named as substituents instead of functional groups. That's bullet point number 3. And then we're bullet point 5, we're numbering as long as possible, the parent chain. And then in terms of order, look at bullet point number 5. Bullet point number 5 says, if there is a functional group, which there is, that has the highest priority before the double or triple bond does. So in this case, if you had something like, let's put the hydroxyl on the other side, over here, you would not number 1, you would start numbering from the opposite side, because it has greater priority as a functional group than the double bond does. So you start numbering here. Do we still have a 5-carbon chain? Yep, so that's pent. So look at bullet point number 1, stereoisomers, don't worry about it, we're not dealing that, you don't have to worry about that. We don't have any substituents. Substituents are, again, other things that are binding to there that are not functional groups, or if you have multiple functional groups, one will be the functional group, the other is going to be the substituent. So we only have one thing, we only have a functional group on there. So we have the parent chain, then stereoisomer, parent chain, substituents, none on there. And now we can name the double bond, and then the last priority, if you're following that order, is the functional group at the very end. So this would be double bond at position 4. And then if we're going to name our functional group, it's at position 1. And whenever we have that, we're going to say ol. So when you see this, you say ol, O-L.
When you see hydroxyl, you say OL.
O-L.
So we need pentanol? But, like, is there a way to write it?
Oh, yeah, that's for sure.
I mean, I don't think you'd be wrong.
Say it again, though. What
Is
did you
there
say?
a way to pull out the numbers so that all are together?
Yeah, if it was, I can. No, actually, it is. It's actually
Yeah.
pentanol.
Good job.
Um,
Oh, you don't say pentanol.
I'll put it at the same side so we can change that. But this is a 5-carbon chain that has a double bond at position 4 and an alcohol group at position 1. So in terms of priority, there's no stereoisomers, so I don't have to worry about that here. There actually is, but we are not going to worry about stereoisomers. Substituents, other things that would be named here, like if there was a chloro group here, that would be a substituent. The parent chain, the degree of unsaturation, and the functional group. That's how it shows up in bullet point number 1. And that's constant. That's
A
hands
lot of
down
steps there.
how you're going to name them each time. Yeah.
So, do we get to use this chart on the test?
Yes.
What was your question, Gloria?
So you name it backwards from priority in which you number it?
Yes.
Okay.
Yeah, that's a good way to say it.
You
Okay, let's put the
Wait,
hydroxyl.
how did you work us?
So like you number it one way and then you write the like wording the opposite.
Oh, yeah.
So if we
Don't
have,
like it, don't like it.
if you have this, the functional group still gets the highest priority, alcohol.
So would you say
It's
the one starts at 1?
It's still 5-carbon chain. We have a double bond at position 1, and we have an alcohol group at position 1 as
So-
well.
Could you just say pentanol?
Yep, so you can say pent
Pentanol.
in ol. Whenever you combine, this
Oh,
is
yeah.
this little guy here. If you're going to add and smash things together, you can drop these off of there. Just like if you're going to take these and smash things together, you drop the YL off of there.
And I'm assuming
it's
we can
similar.
only do that if there's one.
Well, this implies that both of these are at location 1, pentanol.
Yeah.
Yeah.
With the one when it was 4, how do you write that? Like can you still put the words together?
Could you do
But have the
4
4
dash
No.
pentanol?
Yeah.
Okay.
So to Gloria's point, if this is the one over here, right? And you still had to have the 4, 1 ol, there's no way to take these two numbers and put them together because they're each individually identifying both locations
So you
of
can't
those.
put 4 pentanol? 4 dash pentanol?
No.
Because you
So-
couldn't determine whether that was for the,
Right.
hierarchical or.
It would imply actually that that 4 is located on both of those, is what that would
Mm.
denote.
What about 4 pent and 1 ol?
4,
Four pins and 1 ol.
1.
4 dash penting dash 1 dash old.
Yeah, but again, I think that would be implying that you have the 4 for the
Entire thing.
the ene, the double bond, and the 1 is still the ol part of that. So let's do a few other ones, see if we can tweak that out. What if you have,
I have a
I'm listening
question.
to like,
Yeah.
there's so many steps, so
Yeah.
many things to think about.
but again, the biggest picture is stereoisomers, that bullet point 1 you don't do. Let me get you a substituent so you can see what that is. The parent chain, so the length of it. The
It's not necessarily
unsaturation,
hard, it's just like on the test, that I had to memorize like a lot.
so that's double or triple bonds, and then the functional group.
But I thought you said, wait, so why is unsaturation different than stereoisomer when they're the same thing?
This is, if you have a double bond in somewhere, you're actually supposed to say something like cis or trans. And then with that, you're supposed to say how things are rotated around that bond, either R or S. Yeah,
We're not gonna do all that, so you're just gonna state
Yeah.
the fact that there's.
yeah, we're gonna state there is something there, but we're not gonna worry about how, this is
like
called
naming it.
polarization, how it's polarizing light to some degree. Why? Because it deals with organic chemistry, like actually understanding organic chemistry, and we need to not go
So
there.
how do you
No,
do
we
the
not do that.
saturation?
So hang on, let's do a few other ones and see if we can tweak this substituent thing out here as well.
Okay.
So we have, where are we at? 1, 4 ene pentanol. Okay,
I'm just
so
saying these notes are.
1,
Oh,
2,
yeah.
3, 4. This is 5. Okay, there is difference here. No longer are we pent 4 ene 1 ol.
No, we're pent 4 ene 2 old.
Yeah, we are. That is it. We are 1, 1.
Wait,
What?
wait,
No!
No, what is that?
We
No!
are-
Diol?
We are to die ol. Yeah. Yeah, so to your point, you have
What the
2
heck is
ols.
that?
Why
Oh,
can't we
okay.
just put 2 old?
You have,
Okay, no.
so let me break it down. You have a 5-carbon chain that has a double bond at position 4. On that chain with a double bond, there are 2 alcohol groups each at position 1. That's what that would be.
Wait, okay,
So you can, whenever you have multiple identical attachments, that's when you can start using the di, tri, tetra, penta, hexa. Yeah.
why do you have to put 1, 1 if you, like,
Do not break.
if they're both at the same spot? Do you always have to do that just to verify the fact that here's
Yeah,
one of them and here's
And maybe maybe to help a little bit here, when we're doing, this is called IUPAC, the International Union of Pure and Applied Chemistry. It's called IUPAC. But this is the systematic way things were named originally for basic introduction to organic chemistry in college. Since that time, and to your points, things have ebbed and flowed because legitimately, look how simple this structure is. Like legitimately, there's only 2 things really going on, a double bond and an identical attachment. Look how complex the name is getting. So scientists have and continue to try and come up with ways to shorten this. And there are 2 or 3 other methods that are employed. However, that would again requiring the fundamentals so we can know why they've shifted out to the original. What? Tupac?
IUPAC.
Is it
I-
2
It's IUPAC.
IUPAC.
Oh,
IUPAC.
my fault. What does that
It
mean?
was like the science
The International,
squad.
I remember I put
There's a
2
science squad that's naming.
International Union of Pure and Applied Science.
So then that's a 1, 2.
That's a
right?
1, 2. That's a 1, 2,
How would you do that?
right?
So
You
you
could,
put the one. So you put it where it's at on the parent chain.
Yep. and then, go ahead, you're fine, go ahead.
It's just like the
What's up,
silence
man?
blowing the nose. I was like,
What?
the silence is so
You need
loud.
Yeah, you know what? Let me get back to that.
Okay, now we have to be very careful with our numbering. Always before we've numbered from 1 going to 5 because the
Whoa.
functional groups have higher priority than the double bond.
Yeah, but
So
not
you would put
everywhere.
the 1
But
on the right
if-
side, wouldn't you?
If we would have gone 1, 2, 3, 4, 5, this would have been 4, 5, diol. Now we have to be careful because if we do 1, 2, 3, 4, 5, we'll have a 1, 4, 5 triol, right? And that's not as good as having a 1, 2, 5, right?
Trial.
Because again, a 1, 4, 5 or a 1, 2, 5. So you want to start with the numbering system over here, and in addition to numbering over there, we pick up the double bond at the lower numbering system as well. So this would now be what? Okay, so no stereochronous.
Hint 1.
Pint 1 E dash
1, 2, 5.
1 comma 2 comma 5 dash trial.
Trial. It's a trial, guys.
No, but not-
What if you
Right.
had one at the 4 too? Would you still do that because you have the double bond on the other side?
1, 2, 3, 4, 5. 1, 2, 3,
That
4,
would be
5.
easier.
It would still, yeah, good point. So if we put one here, 1, 2, 4, 5, 1, 2, 4, 5. It doesn't matter each way. So it's equivalent, except for now, the double bond comes into play. So you want the double bond now to have the lowest priority if it has to be the deciding factor, so we'd still go this direction. So go this way.
Wait,
Because it would be basically
It would have
symmetric,
higher-
so then you would use the double
So-
bond to determine which way it would go.
wait, wouldn't
Four,
you go
Okay.
5?
Look at bullet
Because it would
point,
literally be the same either way.
look at bullet point number 5 on there.
The parent chain.
No, the one that says, oh yeah, the parent chain should be as long as possible, make sure to include the following items in this order. If it's a wash, to go 1, 2, 4, 5, or 1, 2, 4, 5 for the functional groups, it's
Then
a
you
tie,
went to the double bond.
then the next priority would be give the double bond the lowest number possible. So 1, 2 has to go this way, otherwise the double bond would be at position 4.
What if there's a triple bond between 4 and 5? Then what?
Then you would flip flop
Then
it.
double bond still has higher priority over the triple bond.
Yeah, because it's still higher up on the left.
Question.
Yeah.
Okay, so we have already thrown over that hydroxyl. We put it with the dash OL.
Yeah.
What about methyl?
Yep, we'll do that right now.
Or like
Wait,
the
wait,
other
wait,
ones? And I'm still confused on how you know like which functional group it's in.
Yeah, okay, so let's do this. Notice that on bullet point number 3, it says typically these halides, these halogens, are not named as functional groups, but as substituents. Substituents are named not with the highest priority. Functional groups have the highest priority, then double bonds, then the parent chain, then the substituents. So in terms of what these are, you can literally say other things attached. Methyl groups, ethyl groups, chloro groups, other things attached to there. So in this case, we need to name that as the first priority, or as the first thing showing up in the word, but does it have higher priority than our functional group?
No.
No. So we still need to name the functional groups as having the lowest number possible. 1, 2, 3, 4, or we could go, so 1, 2, 4, or this would be 2, 4, 5. Which one wins?
1, 2,
Okay.
4.
1, 2, 4, also because it picks up the double bond, which still has priority over the functional, or the substituent group here. So now chloro. So 5, chloro. So there is a 5-carbon chain that has a chlorine attached at position 5. On that 5-carbon chain, there is a double bond at position 1,
Oh
and there
my
are
God.
2 alcohols.
This is so long.
Let's get rid of this guy. There are 2 alcohols at positions 1 and 2.
So it's drawn in the backwards order of how it's written.
So
Oh,
5
that's
chloropent,
nasty.
5 chloropent, 1E dash 1, 2
There's no
diol.
dash between the chloro and the
No,
pent.
because those are letters. Keep the letters the same. 5 chloropent, 1E, 1, 2 diol.
Why is that not?
Don't
Yeah,
erase
yeah.
crap.
Leave
Put your hand down before I hit you.
No,
Wait,
seriously,
no, wait,
that's not
I'm
what it is.
like genuinely curious. What does methyl end in so I can write it in my notes?
Methyl?
Cause you know how we put diol?
Yeah, we can do
How
that.
we put it?
Yeah, we can do that.
You're just gonna add it to
Yeah, I'll
it?
add it in there.
Oh,
That's psychotic.
Wait, hold on.
Where do you
no.
put that?
Wait, real quick. So if I had 4 hydroxyls in there, what is the prefix?
Say it again.
If I had 4 hydroxyls, what was the prefix?
Butyl.
H.
It's butyl, isn't it?
Okay, so now, we're building up, same mentality, still 5 carbon chain. We're gonna number the chain based on the highest priority items. That's still keeping this direction. Because this is still a substituent. It's acting as something else that's bonding, that's not a functional group, okay? So substituent, so 1, 2, 3, 4, 5. We know we have 2 hydroxyls at positions 1 and 2 still, that doesn't change anything. Our double bond is still at position 1. Our chlorine is still at position 5. Now in terms of writing out the substituents, they do come in alphabetical order. So not alphabetical here, C and C, that's not what we're talking about. We're talking alphabetical here, N and C.
Wait, it's a substituent?
Yeah,
What about the order, the hierarchy?
Yep. what do you mean?
The hierarchy of functional groups
Yeah.
does not follow that when we get to substituents?
What do you mean?
It's
Like-
not a functional group?
So like, oh yeah, but so the first functional group is the hydroxyl,
Mhm.
because it's highest in the list
Yeah.
of hierarchy.
Yeah,
But then next would be
Yeah.
whatever comes next, but that's not what's next
Yeah.
when you're written
so,
into it now.
yeah, to your point, you only have 1 functional group. After that, everything else is a substituent. When you're numbering substituents or naming them, they need to be in alphabetical order at that point.
Okay.
So this will be chloro is actually before methyl. So 5 chloro, 4 methyl.
So you can only.
So notice the C
Methyl.
is before M in the alphabet. So I alphabetize the substituents. Let me draw, you don't draw lines, but let me draw lines. There's the substituents. There's the parent chain. There's the degree of unsaturation. And here's the functional group. A functional group, which is the alcohol, and they're identical. So 5-chloro-4-methyl pent, 1-ene, 1,2-diol.
That's so long.
Kind of cool though. Yeah, John.
Okay, so
Okay, how do you know, so, what if you take one of the hydroxyls off, then how do you know if it's a functional group or not?
Yeah, still hydroxyls will be the highest. Actually, I won't give you, I don't have any other, I'm not giving you the carboxylic acid, ester, aldehyde, or ketone. Excuse me, so your highest functional group will always be an alcohol. We'll keep it simple.
So-
Because of that, okay.
Yeah.
Okay.
Wait,
So how would you say that long thing? Like, how do you just?
Yeah,
No, I meant like if you took all the numbers and stuff out.
You
So
don't.
it'd
You can't take it out.
be, no, I mean like you know how we said that was pentate
Yeah.
old
Yeah, you
or
can't,
whatever.
yeah, but you can't take them out here. Yeah, you have to leave the numbers in, yeah.
What's methyl?
Yeah, is it a functional group?
It's,
No.
Like what is it? What is it
Like
classified
ketone,
as?
alcohol,
No,
ether, whatever.
What is it
that would
classified
be an
as?
alkane. Alkanes are
Alkane.
alkyl groups.
They're at the
Oh.
bottom.
Alkyl groups are alkanes, and that all have single bonds.
So wait, pens is what?
All have single.
Can I erase?
Pens
No.
is how many
Erase this
chains are
Yes.
in
Okay.
the parent chain. Yes.
Sorry, I didn't mean to yell at you.
Wait a
minute.
Wait a minute.
Yeah,
Oh no.
So technically, methyl is not a functional group. So, if there's no other functional group, but there's still methyl, how do you end it? What is the ending suffix?
What is up with your accent?
Yeah, you had like southern accent today.
I asked this question like 4 times.
let me try this.
Oh, no.
Tell me if this doesn't answer your question.
Okay, it doesn't answer my. Okay.
Is that what you're thinking?
Yes.
Okay.
Wait,
There's so many lines.
Okay,
that-
first off, this
Wait.
is.
no, before we
That's so
completely move
fun.
on,
Yeah.
how do you separate the methyl and pent over there? Is it
You
a
don't.
comma? Do you
Just
just
write them with
words
one
Yeah,
together?
all letters go together.
Okay.
Which is very ugly.
Do you leave
like a space and
Yep.
a, oh.
Yeah, smash these together. Smash them. Methyl cane.
I don't know.
I've never told you this, so there's no reason for you to know this.
I think it's
Are these
6.
two things the same thing?
No.
No.
Yes.
Yes. Wait,
Well,
why?
up to the CH3.
I mean, besides the stage 3,
But
you
isn't
can't
this?
just assume it's methane or methyl on there.
There you go.
Isn't this carbon attached to position 5?
Yeah.
But not if there's a carbon already.
That's a
there.
carbon
So
attached.
wouldn't it
Oh,
be a
and
6?
then carbon is always attached to the hydrogen.
Oh my goodness.
Oh my god, I'm upset with you.
So you, in that case, you would just keep it as the parent chain. That's it. It's not actually part of a functional group. It's part of the parent chain.
Wait, so it's like it's like if you continue, it's like if you added another
Yeah.
one.
So
is there
maybe
another carbon?
let's try this then.
So you're telling me, wait. Okay, just hear me out,
Go ahead.
So on the other end, would it also be assumed that there's 3 hydrogens
Yeah.
attached?
Yeah. Everywhere there's not anything else is hydrogen.
It's just like
Wait a
completed
minute.
hydrogens?
Yeah, so
Okay.
two
Wait a
hydrogens.
minute.
So you don't even have really methyl, you just
Morgan.
have the
Just
parent
carbon.
chain.
Yeah.
So is it really in the functional group
No, it was never
alkane
said.
if it just adds to the parent chain?
If there's nothing else there, it adds to the parent chain.
Oh my goodness.
Yeah.
Methane was never in the
Like-
functional group though.
So, but let's try this though.
But don't you already have the carbon on the end of it? So isn't it a carbon attached to another carbon? So wouldn't that carbon H3 be the 7th one?
All I've done here is I've said make the end of this line the carbon with 3 hydrogen, and that's what this is implied to. Is the end of that line is a so this is the
Because
bond.
it's just
Yeah,
continues the
but when
bond.
you
Carbon.
write it, it's not adding it to the carbon that already exists there.
Yeah, no.
It's just that is bonded
So
to
how would
that
you
bond.
know if it was actually
If you had
attached?
something like this, then this would be 1, 2, 3, 4, 5, 6, 7, and this is the methyl.
So then you would be attaching.
Because now you have a carbon hanging off carbon 6, and the chain keeps on going. So let's try to tweak that out with this, your question here. Should I number 1, 2, 3, 4, 5, 6? Should I go 1, 2, 3, 4, 5, 6? Should I go 1, 2, 3, 4, 5, 6, 7, 8? Or go back 8? Or should I go 1, 2, 3, 4, 5, 6, 7? Like, what's the possibility? So we need to number the carbon chain to be the longest.
Wouldn't it be the longest no matter which way you went? They're the same number of carbons.
But left to right or kind of top to bottom here? So left to right or kind of top to bottom?
Left to
Top
right.
to bottom.
I think
Top to bottom's gonna give you
Okay.
a longer chain.
Because we can get 6 going left to right.
Or 8.
If we go this way, we get 8. If we go this way, we get 8. But if we take this route, we get 7. And if we take
So you
this
just
I
take
said
the
we could
longest
go
route
to
with it.
so we need to
So
go
how would you
somehow.
Wait, name that
want
where
the longest
people.
route?
So
yes.
Okay, but if you're
Oh,
only
shoot.
naming the 8 of them, how would people know that you have like 2 bonds on the other
Yeah,
side?
hang on. So we'll kind of take the longest route, which is this way. Does it matter whether I make this one or this one?
Well, we don't know anything to base it off of yet.
But be careful though. If I number this as 1, 2, 3, 4, then I have some stuff hanging off of position 4. If I number this as 1, 2, 3, 4, 5, then
would
I
be
have
better to have
stuff
the
hanging
4.
off at position 5.
No, you want the position off of 4.
I want it
so
off of 4 because that stuff needs to have the
it's higher
lowest number.
priority than it being.
Okay, so this would be 4, 5, 6,
Yeah.
7, 8. Okay, is this a functional group or a substituent? This will be a substituent. It's not going to act like one of our functional groups. What is it? This is a carbon and a carbon. So if you have 2 carbons, what is that? 2 carbons.
oh.
Ethyl. And are the carbons single bond or double bond?
Single.
So
So it's
that's
ethane.
Ethane. Okay, so what's important there is, and I don't know that I'd ever give you a double, actually I wouldn't, that would totally change things. But don't write this down. If I put a double bond here, the numbering system has to pick up the double bond because that has higher priority than anything else, right? So you would be 1, 2, 3, 4, 5, 6, 7, and that would leave you with this now attached to the side,
Oh, that's
which would be 1, 2, 3, and that would be propyl, right? So you don't need to worry about an ethynyl group, if there is such a thing, or an ethynyl group. There's no such thing as that. Okay, so we have this. We know this is ethyl. So 4 ethyl. attached to that carbon, 4. Keep going, what else? 4
Okay.
ethyl.
Dash.
So that takes care of our substituent, parent chain.
Okay, dash.
Do you need that?
We don't need a dash because.
Oh, no, then you just do oct.
Okay. An
You just do oct.
8 carbon chain.
Octi or
Sorry, oct.
dash, right?
Is there any unsaturation
No,
in functional groups?
no.
So how many, what type of bonding is on that
So it's
parent chain?
octane, 4 ethyl octane.
So without this ethyl group, it's octane. If you have an ethyl group attached at position 4, 4 ethyl. What is just octane? Where do you see that in real life?
Yeah.
Gas, yeah. And then another component of gas is this. Go ahead and name this.
Keep going.
Your ethanol.
Yeah,
What is it?
yeah.
Ethanol.
Yeah. So here's the parent chain, F. This would be carbon 1, 2.
Oh, it's just OH.
So, and the carbons are saturated, so there's our ane. You have a hydroxyl at location 1. So formally, F and all implies that both, or implies that the alcohol group is at location 1. You could have easily have done something, I guess, arguably, you could maybe get away with doing this as well. That there's only one item attached and it's at location 1, ethanol. Alright, let's get a little more crazy.
What?
No, we're already.
Okay,
What?
Can we wait for the crazy till tomorrow?
Yeah, that
So
was
we
already
can
a
work
lot
on
to
these
process.
assignments.
You got it, you got it.
No.
No, 5-minute break, something, Morgan.
Okay, if you can get this one, 5-minute break.
I'm dying. Wait, if we can get it.
Yeah.
So can I
should
go
we
over the
go?
board? Please.
You better make it easy.
You just said it was crazy.
Alright, well, not too bad though.
It's not really.
Okay, let's try this.
Okay, so you're gonna number it, the
Yeah, start your-
one on the right side.
Okay, why the one on the right
Because
side?
it's got the hydroxyl.
The functional group takes the highest priority. Okay.
Okay, so let's start with the CL.
Okay,
Because the C
substituents.
goes first.
Okay, so substituents are anything else that's being attached
Uh-huh.
that's not considered a functional group.
So it's gonna be.
There's only one functional group, even though these show up on your functional group list. If you have a functional group attached, the chain is named on that functional group and everything else becomes a substituent.
Okay.
Substituents need to be alphabetical.
So C before F.
So you have 5.
5-dichloro. Would you do that? Yeah?
If you do that, you have to say where both chlorines are at though.
So 5 comma 5.
5,5-dichloro.
Okay.
Okay. Oh wait. Do we? Yeah.
Yeah, dash.
Okay.
You
Then we
gotta
need
put
the 6 dash fluoro. Then you do the. How is it pronounced?
So that's now the parent chain.
Yeah. Then we do the hex.
Okay, so 1, 2, 3, 4, 5, 6 is hex.
Okay. Then you're gonna do the dash.
No, because it's
That-
single.
That took care of our parent, now we need saturation.
Okay. 2.
So the double bond starts at position 2.
Wait. Would you do the double bond first or the functional group first?
Bullet point 5, this is named last. This is named, or bullet point number 1, 2.
Okay. Got it.
1. This is named last, this is named.
Okay, so 2, and then you're gonna put, in dash 1 dash O. Dash O.
5,5-dichloro, 6,4-hex, 2-ene-1-ol.
That's so chaotic.
Yeah, that was just a lot.
But hey, we got it.
Right?
Unless Mr. Morgan just pulls out, yeah, no, that was.
Yeah, no, that's wrong.
When people put it on like food labels and stuff,
Yeah.
though, they don't include the numbers, do they? So do they just?
They go-
Well, you just say dichlorofluorohex.
They might call
Enol?
this like,
Enol?
they might call, it's not, but they might say like red 40.
Wow.
You know, like they give it a generic.
Yeah, they
name.
just give it like
Why
a
do they
name.
give
They
it
actually
red
name the
food?
compound. Okay.
Because it's so.
Arguably, it's not Tylenol, but they could have called it acetaminophen as well.
But
Yeah,
how do
oh,
they-
yeah.
if it's-
They,
It doesn't
like,
have a
okay.
pre-established name, can they name it whatever they want? And then if they do that, how do you know what it is if that's the only one that's named that?
You gotta look it up.
That's a good point.
Well, wait,
That's-
how
that's
do they
like a
get
patent
affiliated?
If you want to be a
Word on the
pharmacist,
internet.
this
That
is your
feels
life.
like-
That is your life.
How do you
Can't
get,
believe
okay,
that.
so
Alright.
from looking at these
Yeah.
types of things,
Yeah.
and let's say one of them is actually named.
Alright, looks like I'm gonna
Yeah.
end up doing that my
Do
entire
they
life.
just get the name from the color and then the 40 from how many carbons there is?
Could be, or they might just give it a whole new name altogether and just say Tylenol or ibuprofen that has nothing to
Okay.
do
So
with it.
I'm
That's
so
right.
you're telling me I'm about to be doing this my whole life?
Yeah.
Yeah.
All right, we'll take a little break and then I'll draw some up here in the
Wait, you're saying Akira could be my security?
It's not me. What?
Lust.
Akira
was being
could you be my
sadistic.
security at my
Beating up
wedding?
dead people.
For what? My wedding. Like, be the security, so Morgan doesn't show up.
Well, it depends if I'm working. Am I
Here's the
allowed to
deal.
bring my residence?
I know I want to get invited to your weddings. It's perfectly fine. I never invited anybody to my wedding.
No, you're
That's
invited to
kinda
my
weird.
wedding.
But I'm gonna show up. That's the difference. It doesn't
Okay,
matter whether you
see-
invite me or not.
See,
I'm
you
just
have
showing
to,
up.
you
Gonna
have
show
to, you
up.
have to remember, if you show,
Yeah, I'm showing
well,
up.
3 people, if you show up, you're gonna be a really weird white
I know.
guy.
I know that. I realize that. And I'm
It's
okay.
fair.
I'm okay with that. I will be the only weird white guy in the back going, ah.
No, wait, they're like saying their vows and you're like,
Exactly.
They're like, I brought your exam. I'm finally
Number eight,
graduated.
right?
oh my
I've
God.
updated
Numbered it
Skyward.
Fucking hydroxyl is a functional group, right? So it would be numbered from right to bottom. Because it'd be more acceptable. Yeah.
I went back to you.
Yeah, it's like whatever.
So this blue
Yeah.
gets
Yeah, they're
admitted.
still European.
Oh, no.
Okay, but when you get admitted, he's not
I
dead.
started
He's
before
alive.
Yeah.
because I thought it was gonna do something.
Anyways, he gets admitted,
Yeah.
and you have to go through like all these paper processes.
No, wait,
But
yeah,
in the
each
paper
have-
process, it
they
says
each
you
have-
can't smoke,
But,
Yeah.
like
okay,
at
so
all.
my mom's
Yeah.
grandpa, no, my mom's
But the family
my
wants to
mom's
press,
dad
like sue
Yeah.
because we
was an
won't allow
immigrant,
him
and
to
he-
smoke
Yeah.
on the
my
premises.
dad's
So like,
Yeah.
technically, will the
That's
court
also
date,
the
same
will
story.
the, like,
Like,
will the
immigrant
court
from
date
China,
even
so it
occur
was like-
because it's written down
because they didn't
on the
like it, so
paper?
they moved to
I don't know. I don't know.
Because
No.
he gets nicotine patches to get rid of
My
his
dad was
addiction.
born in Cambodia, my mom was
It's
born
more
in Vietnam.
establish a relationship with him. Let him get to know you. Then he might listen.
That man would squash me like a bug.
That's probably true.
He's 475 pounds.
Oh my God.
All right, let's try this.
It's a
It's been
little-
If we name our number 1, 2, 3, 4, that would be 4 hydroxyl. But if we go this way, it's 5 hydroxyl. Which one's better?
What?
Should we go 1,
Oh,
2,
okay, so
3,
that's right.
4 and get the hydroxyl? Or should we go 1, 2, 3, 4, 5 and pick?
4.
Four.
Four for the hydroxyl.
4.
Jesus Christ, that's
Four.
scary.
We
So I
don't
wanna
like
fight
that
boss
all the
break.
time.
It
We
could
want
be.
the hydroxyl
How do I
to be
fight
four.
But we
boss
have
break?
that double
We
bond,
have the
dang
double
it.
bond. Yeah.
I mean,
Wait,
yeah,
so
but the,
what do you think?
the
Is it-
hydroxyl takes priority.
Yeah, but is a 4 and a 5 big enough of a difference to then say if we do 4 hydroxyl, that's 5, 6.
How do I fight boss
6
break, bro?
for the double bond?
Picky.
It says click the line. No, man. Boss break.
I know, but like, oh, matter. Why wouldn't you?
What the? No,
4
that's not boss
full
break.
and 5, 6, 16. So which
Oh
one's,
my God.
which one's better?
Morgan, I swear
Would
to
you
God.
give it the time?
What's wrong?
We're on a short schedule because of IPS.
Oh, are we?
Wednesday.
Yeah, we might as well just
Yeah,
finish.
it's-
No, finish this and then
Tomorrow.
go.
What's
Ah,
this?
Darn, that
Oh, we still
sucks.
got like 8 minutes.
No, we don't.
We have like 4.
Let's do this one.
The
Yeah,
bell
well,
rings
like
at
that.
9:04.
9:06.
No way.
Yeah, we got
Yeah.
It's
Oh,
not
you ain't got
enough.
time.
We got it. I got you. I got you. Which one's
Do
better?
you though?
The 2E or the 5 or the 16?
You're changing.
Ew. You're literally changing the
So
rules as we go.
Is this a big enough difference?
You're the kid that
Oh.
changes the rules of the game while you're playing.
Alright, let's play this game I
Is
made
that how you
up.
play with your kids?
But
Is
like,
that
wait,
really
you
fair?
did it wrong.
This
They're still
difference
learning.
is is not as big as this difference, and this is still number 2 in the hierarchy. So we definitely want to go here. And I can still give us the lowest numbers possible to the highest priority item.
How about I just don't go anywhere and I just don't even name them,
Okay.
period?
Let's do it. Alright, so substituents first.
I think
Chloro
that's better. Like, do you
is
agree?
5 chloro. And then so that's the, forget stereoisomers, substituents, the parent chain. What do we say for the parent? 5 chloro oct. And then degree of unsaturation,
What?
2
E,
E dash 5
5.
dash
Pental? Oh,
Okay, we're forgetting something though.
pental?
Close, not pins.
Oh,
hint.
Not pins.
no.
Oh,
Oh, for those?
Methyl.
Oh, I
So
forgot
it'd
that
be
was
ethyl.
Frack.
So you have 5 ethyl, right? So slide that in there.
Wait, so that counts as a substitute?
5 ethyl. So 5 chloro, 5 ethyl. Oct 2E5ol. Nice. Sweet. Okay, we'll do more examples of this tomorrow, and then tomorrow, Friday, we can have a work day.